In this lecture, we'll be solving proportions. We'll be using cross products to solve. Recall that cross products state if A over B is equal to C over D, then A times D equals B times C. We've already used cross products to determine whether a proportion is true. Now we're going to use it to solve for a variable. We know that 5 times x is going to be equal to 2 times 25, which is 50. Now we solve for x. I'll divide both sides by 5 and get x equal to 10. Same move in the next example. 9 times 0.6 is 5.4. Y times 1.2, 1.2y. To solve for y, all we need to do is divide by its coefficient. We end up with 4.5 is equal to y. Cross multiplying again. Z times 2/3, 2/3 z, and 7/8 times 4/7 gives us 1/2. If you're going to do this by hand, make sure when you're multiplying fractions, you multiply straight across and simplify, or you can use your calculator. To solve for z, I need to eliminate the coefficient, so I'm going to divide both sides by 2/3. It's going to give us z equals 3/4. Again, if you're going to do this by hand, make sure that you turn that division into multiplication by multiplying by the reciprocal of the second fraction. We'll cross multiply to solve 2x plus 1 over 7 equals x minus 3 over 5. Now I want 7 times that whole numerator. So to indicate that that whole numerator is being multiplied by 7, I'm going to have to put the x minus 3 in parentheses. Same thing with the other part of our cross multiplication. 5 times that whole numerator. So we write that 5 parentheses 2x plus 1. To solve, we're going to distribute 7x minus 21 equals 10x plus 10. We have variable terms and constant terms on both sides. I'm going to move my variable term with the smallest coefficient. Negative 21 equals 3x plus 5. We need to move our constant terms to the left. I'll subtract 5 from both sides. So negative 26 equals 3x. Our last step is to divide by our coefficient. 3 does not go into negative 26, and we cannot simplify that fraction. So our solution is negative 26 over 3 is equal to x. We've got a couple application problems here. We want to write a proportion that represents the application and then solve the proportion by cross multiplying. We should be given 2 pairs of information in these application problems. The first pair of information is the first ratio or fraction in our proportion. The second piece of information is the second fraction in our proportion. If a 64-ounce bottle of laundry detergent costs $4, how much would an an 80-ounce bottle cost? Our first pair of information is that 64 ounces costs $4. I'm going to write that as the first ratio in my proportion. 64 over 4. Note that ounces is in the numerator and money in the denominator. When I rewrite the right side of my proportion, I need to keep those units the same. Ounces in the numerator, money in the denominator. We're being asked how much would an 80-ounce bottle cost? The ounce is known, that's 80, but the price is unknown. And now we want to cross multiply to solve. 4 times 80, 320. 64 times x is 64x. The last thing we need to do to solve for x is divide by our coefficient. I end up with 5 is equal to x. It means that that 80-ounce bottle of laundry detergent is going to cost $5. In our next example, we're given a pair of similar triangles. The sides of similar triangles are proportional to each other. We want to find x. We'll write a ratio for the triangle on the left, a ratio for the sides of the triangle on the right, and set them equal to each other. The ratio for our first triangle, x over 15. I'm going to make a note to myself that the side on the left is in the numerator and the side on the bottom is in the denominator. I need to make sure I'm consistent when I write the other half of my proportion. For the smaller triangle, the number on the left is 12 and the number on the bottom is 9. Now I have a proportion that I can solve for. We'll cross multiply. 5 times 12 is 180. X times 9, 9x. To solve this equation, all we need to do is divide both sides by 9. I end up with x is equal to 20. Our last application states the ratio of Hank's income spent on rent to his income spent on car payments is 3 to 1. If he spends a total of $1,640 per month on the rent and car payment, how much does he spend on each item? The first pair of information we were given is that the ratio of rent to car payment is 3 to 1. 3 to 1 is our first ratio, with rent being in the numerator and car being in the denominator. We're told that he spends a total of $1,640 per month on the rent and car payment. But that's all the information we're given. Do they tell us exactly how much he spends in rent each month? No, they don't. So I'm going to call that x, my variable. They do, however, give me the total amount spent on rent and car payment. That total amount is $1,640. Just like in previous application problems, like the distance problems, we're going to let one of them be x, one of the unknowns be x, and the other unknown be the total given minus x. And now we solve the proportion by cross multiplying. 1 times x gives me 1x. 3 times 1,640 minus x is my right side. And now we solve. I'll start by distributing 3 times 1,640 is 4,920 minus 3x. All my constant terms are collected on the right, which means my variables need to move to the left. We'll add 3x. 4x equals $4,920. To solve for x, we're dividing by the coefficient. We get x to be equal to 1,230. We want to make sure to answer the question. They ask us how much does he spend on each item, how much does he spend on rent, and how much does he spend on his car. We know that x is equal to $1,230. X represented the unknown rent. So that means that his rent must be $1,230. To find the car payment, we're going to plug x into this expression right here. It's going to be 1,640 minus 1,230, which makes his car payment $410.